Hello everyone, welcome to our today's session. Gone are the days of exact matches. I would like to introduce today's speakers. Myself, Ramya Mohan Kumar. I am working as a freelance data scientist. Previously, I worked as a data analyst in Northern Ireland Water, Belfast. I also worked as a technical support representative in IBM India's Private Limited. I would like to introduce my co-speaker, Meenu. Meenu is working as a senior data scientist at Carrick Group Limited, Belfast. She has 11 years experience in the IT industry. Previously, she worked with Infosys Limited and RM Education. We both graduated from Queen's University, Belfast with MSc in Data Analytics. In this webinar, we will talk about SQL Joins, introduce fuzzy matches, and a brief introduction about our data science program. Let us start with a problem statement. Consider the scenario where you are a government official and you have data about local businesses. Suppose you have a database with 3 tables which contains information about their sales, employees, and department. All 3 tables have a related column which represents the business entity. The task in hand is to get information about sales, employees, and department of a particular business. SQL Joins is the traditional solution for this problem. You can perform actions on a database using SQL statements. SQL stands for Structured Query Language. A SQL join clause is used to combine rows from 2 or more tables based on a related column between them. Why do we need joins? To join 2 datasets or tables, to retrieve more information, or to filter data, or to reduce duplicate records. Here are the different types of joins in SQL. Inner join. It returns records that have matching values in both tables. Left join. It returns all records from the left table and the match records from the right table. Right join. It returns all records from the right table and the match records from the left table. And the next one is full join. So it returns all records when there is a match in either left or right table. Now let's look at the sample database and tables associated with it. If we need information about Carrick, then highlighted data is what we are looking for. The SQL join statement will look like this. Now, the result from the SQL will be it was a fine journey so far. Now, look at this scenario where there is a typo in the data in the sales table. For the same SQL, we will get only 2 rows instead of 3. Like this. Consider another similar scenario. Left-hand side entries represent the company Carrick, but written in different ways. How do we retrieve information then? Over to Meenu to discuss fuzzy matches.
Thanks, Ramya. So in this case, SQL won't help us because it will be looking for exact matches. That's where fuzzy matches will come into picture. So what are fuzzy matches or fuzzy algorithm or fuzzy techniques? They are nothing but wherein we are not checking whether string A and string B are the same, but what we do is to see how similar those strings are. Let's first look at some of the applications of fuzzy matching. Typos error, that is, if you have spelling mistakes, still it will identify the records correctly. Identify the duplicate records, spam filtering, record linkage. This is where we'll be comparing records even if we are not getting exact match like we saw in our problem. These are few of the fuzzy matching techniques. So you can see like multiple languages can be matched together. We can see similar names, so Carrick Group Limited and Carrick Group or Carrick Group, Carrick Limited. All these three are similar to Carrick Group Limited. So it will identify using fuzzy matching that, okay, if I'm seeing Carrick Limited or Carrick Group, it means or it identifies Carrick Group Limited as the company, like truncated components. It identifies the nicknames, William. Usually William will be called as Will. So those, if in one table I have mentioned William and the one I have mentioned as Will, it will identify it. Spelling mistakes will be identified. So these are some of the techniques in fuzzy matching. So now let's look at some of the methods in identifying a fuzzy matching or some of the algorithms used. Two of them are introduced in this particular webinar. One is edit distance method, which is commonly used. And the second one is TF-IDF method. So the edit distance method will be using on smaller data sets. TF-IDF method will be using in larger data sets. Let's first look at edit distance method. So what is edit distance method? In edit distance method, what we are trying to do is to quantify how dissimilar two strings are by counting the minimum number of operations required to transform one string to another. The most commonly used string distance technique is Levenshtein distance. The Levenshtein distance operations are removal, insertion, or substitution of characters in a string so that it can be transformed into second string. Let's now look at an example and understand more about Levenshtein distance using edit distance. Here, what we have to do is, we have two strings, kitten, that is our string 1, and sitting. The task in hand is to convert kitten to sitting using Levenshtein operations. So how do we start? So we write kitten, and the first is a substitution wherein k will be substituted with s. In the next substitution, what we do is e will be substituted with I. So the remaining character required to get sitting is G, which will be inserted in the third operation. Means the Levenshtein distance between kitten and sitting is 3, which means in 3 different operations, we'll be able to transform kitten to sitting. This is a simple algorithm and very easy to use and understandable. That's why In edit distance methods, Levenstein distance is commonly used. Now let's look at the Python implementation of Levenstein. We'll be introducing two different Levenstein libraries. The first one is the Levenstein library itself. Let's look at the code. So in here, what we are trying to do is we have two strings. String 1 is carry group, string 2 carry group with a typo. And what we are trying to do is in Levenstein distance, there is a function called distance wherein we gave string 1 and string 2 and we have converted the strings into lowercase. And now you can see the distance is 2. That means string 1 can be transformed into string 2 in two different operations. And we can see like if we remove two characters O and U, we'll be getting string 2. So that's why the distance is as 2. The next important function from this particular library is ratio. The ratio will gives us an idea about how similar both strings are. Higher, the better for similarity. In this case, the ratio is 90. Means strings are very similar. Let's look at another example. In here, we have same string 1, but the string 2 has changed to ABC. In here, we can see the distance now changed from 2 to 10 because it needs a lot of operations to convert string 1 to string 2. Same with the case of ratio. Here, ratio is 14, which means the strings are not similar. Let's go to next example. In here, instead of Levenstein distance, Levenstein library, we are using a different library. Name sounds funny, but it is really used in most of the companies when they deal with fuzzy matches. The name of library is Fuzzy Wuzzy, and they have a lot of different functions which can be used. First one is ratio. So we have string 1 and string 2. The ratio is giving us as 85%. Let's look at another function called as partial ratio. So the partial, what is the difference between ratio and partial ratio in Fuzzy Wuzzy is, in partial ratio, what we are trying to see is the similarity score of shortest string in the second string. Means, so let's see like string 1 and string 2 are here. String, we can see that string 1 is shortest compared to string 2 in this scenario. So what we try to do is, we'll try to see how similar string 1 is inside string 2. So we can see like carry group that string 1 is entirely inside string 2. That is why we are getting partial ratios 100. Let's see an example, similar example, but with a some typo. So here we can see string 1, what we have done is we made a typo here, and you can see like group U is removed from the first string. So now the string 1 is not exact match as string 2. So in string 2 group you have U also, but in string 1 U is missing. So that's why the partial ratio is coming as 90, wherein in the first case we had group entirely inside string 2. That's why in the previous example we have seen partial ratios 100. So that's the difference we'll be getting. So we can decide when to use ratio and when to use partial ratio in our projects. So far we were looking at matching a string with another one. Suppose if you have a string and if you want to compare it with a list of strings, then what you can use is, from the fuzzy wuzzy itself, we can use extract method. So here what you do, you'll give a string and it will be compared against multiple string options. So here we have string to match as carry group, and we have given different options here, around 7 options we have given. So if we use extract method, what we get is our first string to match, will be compared with each of the strings in the list and will give us the ratio of each of them. And it will be giving the most similar scenarios alone. If you see, you can see here, like we got most of them, but XYZ, UT, those are not written. So it was trying to give us most exact ratios only. Suppose what your case is not to identify all the similar strings from the list, but your task is like you have to see the string to match and see from the list which is the most similar match. Only one option you want to take. Then what you do is, instead of using extract method, you will be using extract one. So if you use that method, you'll be getting the most similar, the highest ratio you will be looking at, and that will be returned. So that is what we are getting as the second result. So like mentioned earlier, if we are having a larger data sets, usually fuzzy wuzzy won't give us a good result. Like it will give result, but the performance will be a problem. Computational efficiency won't be that great. In that case, we'll be using a different library, which is TF-IDF matches. And it gives, so our task if is to compare two columns in a data set or table. Two tables are there and we want to compare columns. In that case, you can use Levenstein distance or fuzzy wuzzy or TF-IDF. Usually I'll be going for TF-IDF matches, because here I don't have to do more coding. I can tell like, okay, string one. So instead of whatever I have given here, I'll tell like string one is equal to values from that column. String options is equal to value from the next column. And then we can compare using matcher method. So in matcher method, what happens is, so we'll be giving first list of strings, comma, second list of strings, comma, then you can give k underscore matches. So here what you're trying to do is you are giving like, so in this scenario we gave 2. So what it will do is it will look at the first string of the first list. So here we can see carry group L is the first string. It will be compared against the second string, list all the elements in that particular list, and will take the most similar strings and it will give. In this case, we are telling like give the most similar two strings back. So that's what k matches will be doing, and we gave 2. So most similar 2 strings will be given back. And what is match confidence in this particular table? It is nothing but cosine distance between the matches, which is normalized to 1 and 0 and 1. 1 means it's exact match with whatever original value we are having. 0 means the strings are not at all matching. In our case, we are fortunate that we have strings which is almost similar to the string which we are having in both the list. So in the first case, the first line says the match confidence is 0.89. The original name is Carrick Group L, and we can see in the second, like we have Carrick Group Limited, so it's almost similar. That's why we are getting like 0.89. In the second line, we can see the match confidence is 1, and the original name is YUT. And in the second string list, we can see like exact YUT is there. So that's why we are getting a match confidence of 1. So that is about fuzzy matches and two different methods, edit method and TF-IDF methods. If you have any questions, you can post it in the chat. We'll be discussing once we finish. So let's go and look at the data science program which we are offering you. So these are the details about our program. It's a 6 weeks program. We'll be having mini hackathons in between. It's interactive session, so we'll be having weekend classes. And there will be one-to-one training sessions with trainers. And the course fee is £500, and we are offering a discount of 10% for people who attended this webinar. And these are the modules which we are covering. We'll be covering about Python. The entire course will be taught in Python. So we'll be giving an introductory session on Python. We'll be giving hands-on and assignment on it. Then we'll be having statistics fundamentals. Then we'll be doing exploratory data analysis, data visualization, and then we'll be diving into machine learning concepts. So we'll be learning about most of the common algorithms used in machine learning. We'll be looking at natural language processing. And then the last module is deep learning, wherein we'll be covering about neural networks. So this is the methodology which we are planning to use. So on Sundays, we'll be having the classes will be like 5 hours. So for the last batch, our time was from 7:30 to 12:30. So in the class, we'll be discussing about theory and mathematical description of the topics which we cover on that week. We'll be showing example with code. Then we'll be having hands-on. We'll be sharing assignments so you guys can go back and work. We'll be exploring real-world projects. So we'll have discussions, case studies, and research paper discussions.